All right, welcome back from spring break. Hope you all had a good spring break, and didn't go stir crazy at home. It was definitely different for sure. We're gonna pick up where we left off. I had mentioned something about extending this unit and talking a little bit about nutrition. This is going to be an important part of the rest of your life. So it's not good to understand a little bit about nutrition as far as how what's the purpose of it? Why is it that we eat? You're going to get energy, okay? And how does your body do that? And some other things that go along the way as you will continue to use this information to help you with your assignment today. You'll be tracking your diet, things like that. There's a lot of companies and stuff that is a multi-billion-dollar industry. Nutrition, it's growing field. If you're interested in it, there's a lot of room, and they can't simply hire enough registered dietitians or nutritionists or things like that. So it is a growing field. We have talked a little bit about nutrition, mostly looking at and discussing a little bit about the macromolecules, carbohydrates, lipids, proteins. I want to get into a little bit more about how you get energy from it, how you get from a macromolecule to ATP for the most part. Now, I'm not going to cover any um, review on cell respiration. Those being your three processes that's going to create ATP: glycolysis, Krebs cycle, and electron transport chain. You just need to know that that's how your cells are going to create adenosine triphosphate, which is ATP. So the process of this is to get from food, and how do we get energy, right? So that's our overall goal. So first, nutrition is the science that investigates the relationship between a physiological function and the essential elements of foods eaten. Okay, so that is simply what we need for our body to survive and what we eat. The science of that is nutrition. Okay, so to put it in what is called layman's terms. Now, there is a difference between hunger versus appetite. I'm a person that will be watching TV out in the living room, and I think I am hungry, and I'll walk up and go check the fridge and take a look, sit back down. Commercial comes on, go do it again. It's more so boredom. There's more uh, something psychological to it. Okay, so a hunger versus an appetite. Okay, hunger is a physiological need to eat. Your body is pretty much being starved and needs to replenish in order to make energy and to build things. Appetite is a desire to eat. Now, the scenario that I just described, that's more so boredom than anything. But there is a difference between hunger and appetite. Hunger being physiological, and appetite being more psychological, or at least having a psychological opponent to it. An example of that is if you see something that is, that you crave or you like, and then you end up becoming hungry from that. It can work the opposite way as well. You can lose your appetite, as one would say. No one ever says you lose their hunger. Okay, but you can lose your appetite, and there's a lot of marketing schemes and things that companies do to increase appetite, such as the colors of their logos, things like that. Red and yellow tend to appeal to and increase appetite, so therefore you're going to be more hungry. Now, that energy that we're talking about is going to be a measurement called a calorie. Now, I do want to go into what a calorie is. Okay, it's a unit of measurement that indicates the amount of energy obtained from a particular food. Okay, excessive calorie consumption is a main factor in the tendency to be overweight. Now, how this works is your body's going to, or your metabolism, as people would say, is what is required for your body to function. Um, and burn that energy burns by your body. Okay, and your diet is going to be calories consumed. Okay, metabolism is calories burned. Okay, so calories in, calories out. If you have more calories coming in than you do going out, you're going to hold on to those and store those as in fat. You're going to gain weight. It's about every 3,500 calories is a pound of weight. And then, so therefore, if you are at an excess of 3,500, you gain a pound, and that's a pound of fat. And if you're at a decrease or a deplenish of 3,500, then you're losing that. So it's really, weight loss comes down to a simple calories in, calories out. And how you do that, there's a lot of different ways. And there's not a specific cookie cutter way. It's simply just more calories in, more calories out than calories in, and that will lead to weight loss. So we had a little bit of a project or an assignment with that, so I'm not going to go into that. Okay, but I do want you, for your assignment, you will need to know caloric conversions. Okay, you will be tracking your diet given day. Okay, a lot of people do these. There's a lot of apps, things like that you can do. You just plug it in there, it can do it for you. That's fine. You probably have it on your phones right now, so you just have to track your conversions or your meals, and it'll tell you everything for you. That's fine if that's what you want to use. If not, then you're going to have to look everything up. But I want you to understand where you're getting your calories from everything. Okay. We have a general idea. You eat food, you get energy. Well, what's providing that energy, and how much can we get into it? So our energy is mainly coming from one or three different macromolecules: carbohydrates, proteins, and lipids. Carbohydrates are going to be 4 calories per gram. Okay, so underneath here you have an example: 10 grams of sugar will have 40 calories. Protein, 4 calories per gram as well. So carbohydrates and proteins are going to be the same. 10 grams of protein will equal 40 calories. So these are just examples here. And then you have your lipids, which are 9 calories per gram. So more calories in the lipids. Now, something here, we can get into the morals and ethics of actual food labels. But what is actually put on there is not necessarily true. The FDA, which is the Food and Drug Administration or Association, one of them, not the Future Doctors of America, but the Food and Drug Association or Administration, I believe is what it is, allows kind of these fluctuations, percentages in which you can put on a label. Okay, it's not too much, but that's why you see everything being 100 calories or whatever it may be, because they have somewhat of some fluctuation there, and that these are all based off a 2,000 calorie diet. And also the biggest thing is to look at serving size. Okay, so when you're looking and counting calories and things like that, take a look at the serving size, because you may see something like a 90 calories here. Well, there's 20 per container, and one pretzel of those, one serving size is going to be represented on your nutrition label. And if you eat the whole bag or 20 pretzels, you can multiply all this by 20. So that's how nutrition labels and things are going to get you. So make sure you look at serving sizes and things like that, so that way you know that what you're actually eating. Also, I want to talk about water. Water is a huge part of how your body functions. We're 50 to 60% water, and if you lose, don't quote me on this, but I believe it's somewhere about 5 to 10% of your water, you end up dying. Okay, so it doesn't take a lot of water for you to lose to really affect you. Okay, and that's why you can only survive certain minimal days without water compared to eating. Your body is going to pretty much eat itself. So it's there. What's there is, you can go through and read all that. It's nothing really new or Anything I need to go over? Now, 6 to 8 glasses is what's recommended. Okay, you're looking at glasses being about 8 ounces. So you're looking at about a half gallon of water a day. That's about what what is recommended. Those that are bigger, a little bit more than that, and those that are smaller can get away with 6 to 8 or 6 glasses of water. But you do need to have water. And actually, how you hydrate, and you only get about 60% of your water from drinking. You get about another 30, 25, 30% from eating and breaking down and metabolism and things like that. And then um, the other 5% coming from the actual food itself. So that is a little bit about water. Now we're going to get into the macromolecules. Now I'm not going to try to bore you too much about the biochemistry of it. Okay, for those that want to go on, this is going to be probably one of the hardest classes you will ever take in college if you want to do a medical major or anything like that. You have kind of the make or break classes, that being biochem and organic chem, because it's just very hard and there's so many different molecules and things like that. So I don't want to get into too much of that, but do give you an understanding of it. So we'll get into that with proteins, fats, and carbohydrates before we move on to some minerals and things like that. So proteins, they play a role in developing and repairing bone, muscle, skin. They're used for everything. I'm just going to put it out there. They're just used for everything. Just proteins carry out life functions. Okay, they're a key element in antibodies, protect us. I'm going to keep going on and on and on. Okay, so where do you get them? Here you have some. You have animal proteins, you have plant proteins, you have grains, nuts, things like that. So you have different types of proteins that your body is going to need. Now, the reason why you need to, for those that are not wanting to eat animal products, things like that, you have in your body what are called essential and non-essential proteins, or amino acids for the most part. Remember, a protein is made up of an amino acid. So this diagram here is a very, very simple. It took me about 20 minutes to find a diagram that could actually put on here, that not to overwhelm you guys. But you have essential and non-essential amino acids. The essential amino acids are the amino acids that you have to get in your diet. Your body's not going to be able to produce those. Okay, non-essential, meaning that your body already has those and they're not essential to your diet. So you have to be aware that you have and you need to have the essential amino acids in your diet, whether you want to not eat animal products or not. And you have to look into exactly which ones are essential and non-essential. But so here you go. You have proteins. That protein is going to get broken down by a process called hydrolysis. That's pretty much you're making water. You're taking out hydrogen to make water, and you're going to make amino acids. Well, the easiest way, there's two ways they're going to be used. One is they're going to make proteins. Okay, that's what synthesis. You're going to take these amino acids, you're going to build them up, you're going to make things like heme, nucleotides, hormones, neurotransmitters, and the list goes on. You're also going to make proteins here. These you'll see more so for building structures such as muscle. Then you're going to have an oxidative deamination. Okay, that is a fancy term for pretty much picking apart a carboxyl group. Okay, this carbon is going to form that carbon skeleton, which is part of a carboxyl group. I'm not going to get into the construction or the structure of the molecule, but you have a ammonia molecule here, or NH3, that is going to get broken off. And now this is the part here that is toxic. So your body is going to react in what is called the urea cycle to produce urea. So it's going to be able to get rid of that. Now, if these levels get too high here, it's going to damage your body. Okay, and what happens here is if you start to produce and metabolize a lot of muscle, you're going to get a lot of ammonia, which your body's going to have to try to keep up. And if you get too much, your body has a rate at which it can only keep up at so much. Okay, so that's why you look into the keto diet. Well, you're pretty much starving yourself of energy, and that energy. So first, you're going to use carbs, then lipids, then protein. So if you aren't getting those, pretty much what's going to happen is your body's going to end up using that muscle and creating a lot of ammonia here, which is not necessarily good. But the other part of that is going to get broken down into this process, which is called transamination. Okay, is you're going to take this, what is a alpha ketoglutamate. Simply put, you're going to make glutamate, okay, and then that glutamate, you're going to make keto acid, okay. So carbon cycle is going to make keto acid, which is going to get turned into pyruvic acid, okay, for those that are glucogenesis, and then also can get turned into acetyl-CoA and acetoacetyl-CoA, which are going to be used in the Krebs cycle here. So the skinny of it, I should say, protein gets broken down into amino acids. Amino acids can produce ammonia, which then your body gets rid of. Then the leftover, the carbon, is going to produce glucose or ATP as it enters the glycolysis. Okay. Also, it's going to enter, or some amino acids are going to get broken down and enter the Krebs cycle, and eventually going to the electron transport chain, which energy. So, like I said, that is a very, very brief breakdown of what that and how that goes. All you need to know is that proteins make energy, and they actually only make about 10 to 15% of the energy required or that we use. So it's not talked over as much, and it is the last kind of energy source compared to carbohydrates and fats. And all this is really happening in the liver. Okay, so once everything's broken down, it's going to get put into the liver, it's going to get synthesized, and then pretty much determined whether you're hungry or you're fed, you have food in your body, or you're starved, and that's going to determine. If you're starved, you're going to get broken down into here. Okay, so if you're starved, meaning you haven't eaten hours within your meal or so, you're going to get broken down here. And if you are fat or so, you're going to get more energy out of it, but you're not going to get this ammonia as much. So next is carbohydrates. Now, carbohydrates are the simplest. You get most energy from it. It's basic. I'm not going to get too much into it, but I do want to talk a little bit more about these carbohydrates and how it gets into these single molecules. Okay, so the basic nutrient that supplies the body with energy needed to sustain normal activity. Simple sugars found in fruits. Complex are found in grains, cereals, vegetables. Monosaccharide is going to be what is called the building block. That is a single molecule of sugar: glucose, fructose, galactose. Examples of what are monosaccharides. Then you have what are disaccharides. Di meaning two. So it's just a combination of two monosaccharides, and that is sucrose and lactose. Okay, sucrose being your regular table salt. And then you have what are your complex carbohydrates or polysaccharides, and these are long changes found in starches and fibers. Now, so we're looking here. Here's a complex. This is kind of this reason why complex carbohydrates are better than simple carbohydrates. These are all simple. This thing would go away. But down here, monosaccharides are going to be simple carbohydrates. So there's no breaking down process. But when you have a complex carbohydrate here, you're going to be able to break this down, and it's going to require a little bit more difficult to break down. Now, I want to look at these two things here. This is biochem right here. Okay, so, and kind of organic chem all wrapped into one. This is why you look at this and this is just crazy. Well, this is just glycolysis. This is the first part of cellular respiration. There's three other parts. This then is going to go into the Krebs cycle, which is very similar to this. It's just going to go around and around and create a lot of high energy electrons where you end up getting adenosine triphosphate. Okay, but you're pretty much taking a long chain of monosaccharides, breaking them down into monosaccharides, okay, and then these monosaccharides, okay, or these glucose can get used in glycolysis. Pretty much then it gets broken down. After glycolysis, it's going to get made into pyruvate, and then pyruvate is going to get used into the Krebs cycle. I'm not going to go into this whole idea of this. Just know that this flows straight into your metabolism, your cell respiration, which creates energy. So this is why it's the easiest, most sustainable. Is that if you look at these glucoses and things like that, it's just straight here. It goes straight into this. There's no detours, anything like that. It can go straight into producing energy. Now, this is going to be located in every cell. It's in the cytoplasm that glycolysis is going to happen. Then it's going to go into the mitochondria. It doesn't produce a lot of energy as far as the glycolysis, but then you have Krebs cycle, and then finally electron transport chain that is going to get energy. Now, fiber. Okay, that is bulk or roughage, green leafy vegetables, grainy cereals, things like that will have fiber, and pretty much it's to keep you regular. That's pretty much what it is. So fiber is going to help absorb water. You don't digest fiber. Okay, so by keeping fiber, it's going to absorb that water, so it will soften your stool. So if you need that, then just know to eat some foods with high fibers. That's why you see, vegetables and things like that. Let's get into fats and lipids. So this is this here is a little bit different. You can get pretty much where your fats and your lipids are going to generate energy from. It's going to skip glycolysis, because glycolysis is just splitting a glucose. Well, we're going to start with a fatty acid, and it's a little bit different in that process that it's going to happen. But you're going to break it down into two structures, either acetyl-CoA, or you're going to break it into acetyl-CoA. Okay, so all you need to know is that these molecules are going to enter what is the citric acid cycle, or the Krebs cycle, same thing. So different types. You have fats, you have oils, you have saturated, unsaturated, trans fat, hydrogenated. A lot of different things that can help, but one is going to help carry fat-soluble vitamins A, D, E, K. So in order to uptake these vitamins, you need to have some sort of fat. In order to do that, it's going to act as a vessel or so, and it's going to provide energy and simply taste. All right, so that's one thing you want to look at if you're looking at diets: low sugar, high sugar, low fat, no fat, low salt, things like that. Yes, one may be low, but they don't want to sell something that doesn't taste good. So if fat's low, look at sugar. If sugar's low, look at salt. So they kind of just fluctuate these so that way things still taste good and people will buy them. So here you have a diagram. Okay, I wanted to, like I said, I'm not going to get into the biochemistry of it, but you do need to understand that you're going to get kind of these two different routes here. Here you're going to get the glycerol. Remember, you have fats. They're going to be, if you look into the structure of it, you have what they're called triglycerides, these three chains, to say the most. Or three fatty acids that are connected by a glycerol. And what's happening is these lipases are going to break apart those. Okay, it's going to break it apart into a glycerol and a fatty acid. Okay, so that glycerol is going to go through pretty much going into breaking it down to eventually glycolysis, where then pyruvic acid, acetyl-CoA, and into the Krebs cycle. So once again, you're going to have a little bit going on here, glycerol into glycolysis, then to acetyl-CoA. But these fatty acids here are going to get oxidated and get pretty much restructured into acetyl-CoA or acetyl-acetyl-CoA. Okay, pretty much just enzymes, things like that, breaking them apart. So that way you make acetyl-CoA. Once again, that goes into the Krebs cycle and then makes what comes out of the Krebs cycle can then make energy in the electron transport chain. I know it's probably the boringest thing you've ever said, but like I said, I wanted to give this some preview into kind of medical school and things like that. You will talk a lot more into it, not just nutrition, but with medicine and things like that. So this is a very, very, very abbreviated version of this. And if you need help on this understanding, I will be available through Google Meets, Hangouts, whatever it is at the beginning of class. I guess you're probably listening to this right now. But if you need help, say Friday, or just have any other questions, you can log on, let me know, and I can help you out and understand a little bit more. So remember, the idea of energy is ATP, food, things we consume into making ATP. Cells then can use ATP. Everything is how you make ATP. Glycolysis, Krebs cycle, electron transport chain. So it either needs to enter the electron transport chain, or sorry, the glycolysis or the Krebs cycle. So amino acids are going to get broken down and either make enter both. Same thing with lipids, and glycolysis is straight. You don't have to break anything down. It's going to get right into it unless you have to break down the molecule itself. Now, vitamins, minerals, things like that. I want to talk a little bit about this, not too much, because there's a lot of them that I can't spend that much time on it, and you probably fall asleep by the time I'm done talking about this. So vitamins are essential organic compounds that promote growth and reproduction to help maintain life and health. Pretty much what you need to know is you need them. You have two types: water soluble, that's your vitamin B, vitamin C. Now, a lot of times people think that you just eat these and pee them out real quick. That's not necessarily true. Sometimes they hold along, but what happens is you end up replenishing them. Okay, so when you do replenish them, then you will rid them of your body. But you will have to consume a very large amount in order to get into toxic levels because your body can get rid of them. Now, fat soluble, though, A, D, E, and K, those your body's going to hold on. So you got to watch those levels a little bit more. And monitor that. Minerals. Okay, minerals are going to be inorganic, indestructible elements that aid in the body's process. Without minerals, vitamins cannot be absorbed. So they kind of work hand in hand, right? You need the minerals in order to absorb the vitamins. You need the fat in order to absorb some of the fat soluble vitamins. So these go hand in hand, right? A lot of times when you're doing blood work and things like that, this is pretty much what they're looking at, is these micronutrients, minerals, vitamins, things like that. And because this is going to pretty much run your body, okay, as far as how your bones are made, how your heart beats, how it only takes a little bit of deficiency in potassium in order to fluctuate the arrhythmia of your heart. So you have a lot of different blood tests and things, and what they're looking at: iron, sodium levels, as far as high blood pressure. I mean, you have so many different things, but pretty much what you need to know is that it's going to be inorganic materials that's going to help with body's process. What about food allergies? Okay, well, food allergies are similar to regular allergies, and where it's pretty much your body is thinking it's being invaded by a foreign substance and it's going to attack it. Okay, so it's an overreaction. are really not harmful, but your body thinks they are, so it's going to go through and attack it. Okay, which are perceived as allergens. All right, typical food allergies: milk, eggs, peanuts, soybeans, tree nuts, fish, shellfish, and wheat. You have different ranges similar to that of regular allergy. These are different than regular allergens. When you have an allergy attack, you see it more so of rashes and swelling. Okay, you can get into more violent things such as vomiting, diarrhea, and enough swelling to close your throat, eventually death. So those are things, epinephrine or an EpiPen, Benadryl, things like that. If you have one of these food allergies, it's a pretty good idea to keep some of those handy. Now, an intolerance is pretty much your body's unable to break it down, such as lactose or additives or things like that. So if you're lactose intolerant, your body lacks the enzyme to break down lactose. Okay, so your body can't digest lactose, and it's going to result in some sort of way to get rid of it. Okay, so that was the last slide. Our quiz on Friday is going to be on nutrition. Welcome back, and enjoy your diet analysis. It's really the only thing we're doing this week. Okay, is this the diet tracker? Sorry, not diet analysis, diet tracker, where you're going to be calculating and answering some questions and things like that kind of we talked about. So enjoy the week.